Boys and girls, welcome back to our channel. In this video, we are going to understand further about the other modes of heat transfer. Before we could proceed, let us recall that heat energy is that form of energy which is always in transition from a body at higher temperature towards a body at lower temperature. Now, this particular heat transfer is possible in three different manners. One is conduction, the second is convection, and the third is radiation. If you are joining onto this video directly, please check out the description. There is a link for the video explanation with regards to the process of conduction. As mentioned, let's try to understand what convection is in this specific video. Now, whenever we heat a substance, we pretty well know that the molecules of the atoms, or rather in general, the particles of that particular substance will be able to absorb that particular heat energy, and now they start vibrating either with a greater amplitude or rather more vigorously. Now, on heating a material, this is what the particles will be gaining more energy, they speed up and they take up more space. Now that we are considering the concept of convection, let's try to understand that we have a particular physical quantity called as the density, which is referred to as the amount of mass present per unit volume. Now, as mentioned here, when we heat up a substance, the particles will be vibrating more vigorously. They would tend to occupy more space. If more space is occupied, automatically the volume which is there in the denominator would increase. When the volume increases, automatically the density of the substance would in fact decrease. When the density decreases, this is the key for the concept of convection. Whenever the density decreases, the lower density substances would always rise up. The higher density substances would always tend to sink down, or they would tend to fall down. Now, based on this specific idea, can we now try to understand why is it that an air conditioner is always installed near the ceiling while a heater, a room heater, is always installed near the floor? Take a moment, take a gap, pause the video, think about the reason, and we shall come back to the actual answer in just a bit. Now, what exactly is convection? It is in fact the flow of heat through a fluid from places of higher temperature to places of lower temperature by the actual movement of the fluid itself. Now, in the case of conduction, we understood that conduction is the heat transfer mechanism generally observed in solids. When it comes to the concept of convection, this is generally observed in fluids. Now, when we talk about fluids, we are talking about both liquids and gases together. In the case of conduction, we need to further understand that the particles themselves do not get displaced completely from their mean positions. The particles will in fact vibrate with a greater amplitude, but they would never get displaced away from their mean positions. But then in the case of convection, the substance which gets heated up, that is a layer of water or a layer of air or a layer of gas, whatever is getting heated up would actually raise up. Now, why is it that they would rise up? It is because the density of that particular layer or of that particular substance would drop down. So, the lower density substances or layers of the fluid would rise up, as shown in this diagram here. The hot water molecule would in fact rise up, while the cold water molecule would drop down. This indeed is the process of convection. Will convection, do you think, take place if water is heated at the top rather than at the bottom? Well, the answer is pretty obvious. No, as the warm water will always be less dense and therefore it will stay at the top only. This in fact explains the reason. If you go back in our slides, this in fact explains the reason as to why the air conditioner is always installed near the roof or near the ceiling. It is because if you want to cool down your room, you would like to have the AC installed near the ceiling so that the air present near the ceiling could be cooled down. When that air is cooled down, the density would increase. When the density increases, that cool air would drop down near the floor. Eventually, this cycle repeats itself and all of the room, the entirety of the room will now get cooled. In the converse manner, if you have a room heater installed near the floor, the air that is present near the floor would get heated up. When that gets heated up, the density of air would fall down, would decrease. Less dense air would now move up. When this less dense air moves up, automatically the air again available near the floor is in fact would be having a higher density, which means it is a bit cooler. Therefore, this cycle also continues to repeat. Now, if at all we install the heater near the ceiling, near the roof, what is going to happen? It will heat up the air near the ceiling only. It will heat up the air near the ceiling, and the air near the ceiling only would be hot or warm, and that warm air would remain only there. The air near the floor will continue to be cold, and it would not serve the purpose of making use of a room heater. Right, so we could also understand the concept of convection through the process of, the convection currents in the Earth's atmosphere. Near the equator, the temperature would be on the higher side, because of which the air present near the equator would get heated up. That hot air would raise up, creating a low pressure region here. Because of this low pressure region, the air that is present from the poles would rush down over there near the equator, while the warm air, which is less dense, would in fact move up towards the north poles. This in fact creates an entire convection current within the Earth's atmosphere. If you want to learn a bit more with regards to the concept of convection currents and how it is, applicable in our daily life with regards to the convection currents in the Earth's atmosphere, you might want to have a deeper study in the field of geography. That would really help you. Apart from this, you also notice a diagram here on the top left corner. It talks about a sea breeze and a land breeze. On the top left corner here, it shows during the daytime, when the sun is shining, both on the land as well as on the water body simultaneously, you pretty well know that water's specific heat capacity is extremely high. It means we would require a very high amount of energy to heat up water in comparison to heating up the land mass. Automatically, the land mass would get heated up much faster, and when that gets heated up faster, the air present on top of the land would also get heated up faster. That air would now start raising up. When this air raises up, there is a low pressure region created over the land mass. Therefore, the air that is present on the sea, on this water body, would rush up onto the land. Since the air is now moving from the water body onto the land, it is called as the sea breeze. Now the warm air that has risen up would in fact complete the cycle. It will drop down here on the water body, and this cycle repeats itself. Now the same thing here in the opposite manner happens at night. Water is extremely difficult, or rather it absorbs a lot of heat energy for the water, to get heated up. At the same time, it will also take a lot of time to cool down as well, at least in comparison to the land mass. The land mass can get heated up faster, and it also will get cooled down faster, which means during the night time on the land mass, the temperature would drop down faster than on the water body. Because of that, what happens now? The air that is present on this particular land mass will be cooled down, and there would be a very high amount of air or a high pressure region created over the land mass. While at the same time, the temperature of the water body would be higher in comparison to the temperature of the land mass. Therefore, the air that is present on top of this water body would rise up. When this rises up, it creates a low pressure region. Thereby now air would be blowing from the land mass onto the water body. Therefore, it is called as a land breeze. I hope you understood how the convection currents work here. The same explanation was given to you already with regards to the room heating mechanism. The hot radiator present on the floor heats up the water, goes up. There is a cold window, there is a window open, so there is air flowing in. So the cycle here rotates or repeats itself continuously. Convection in our daily life, a hot water system. This is how we can in fact utilize hot water system as well. Now let's try to understand the diagram given here. Let's look at this boiler. Right. So we are supplying heat energy right at the position of the boiler. There is water present here, which means water will get heated up, and that hot water will start rising up. It starts rising up, it goes into the hot water storage tank. But then the hot water will stay only at the top, while at the bottom of this hot water storage tank there will be cold water filling in right at the bottom. Now where is this coming from? Where is this cold water coming from? It is coming from the cold tank up there. You notice that cold water would come in there. There is cold water here. That cold water will be supplied to the boiler. Water will get heated up and it will rise up here, which means at the top there is always a certain amount of hot water present. When the hot water present in this hot water storage tank is sufficiently higher, that will rise up and we will be able to access it through our tap. In case there is a very high amount of cold water present, or rather hot water present, that will rise further up through the expansion pipe, and that water can be collected in the cold tank. So this is a cycle that again repeats itself time and again. Moving on, a freezer compartment. It also works in a similar manner. The freezer compartment is a region where the cold air is present. That cold air, if there is air that is present near that, that air will be cooled down and will be sent down so that the entire freezer will continuously have a convection current flowing. So I hope all of you now understood the concept of convection. If you have more questions, feel free to contact me. Thank you and goodbye.